So this is a typical problem that you will find in your exam. It doesn't matter who the professor is or if he's as crazy as I am. You're gonna get this type of problem for sure. So picture that you have a fancy helicopter that's gonna be here. Normally I would like try to draw a helicopter, but given that these things I won't even try. Okay, so this helicopter is just like flying, and it's just like 100 meters in the sky. Okay, and it's flying at a constant velocity of 25 meters over second. With an angle of 36.9 above the horizontal. And there you go. Okay, so it's flying over there and it throws a package into the air, and we need to know how long is the package in the air. Okay, so this thing is gonna go like all the way through here and until it lands somewhere over the lake. Okay, so we need to know the time all this time, which we don't know. Okay, so how do we solve that? Well, we first need to settle that equation. Okay, so we can start by saying that y equals y0 plus the velocity in y times time minus half of the gravity times squared. Okay, yeah, so it's gonna end at the floor. Okay, so this is 0, so we write 0 here. Initial position is 100 in the y-axis. Velocity in y, it's 25 sine of 36.9 times the time minus a half of 9.81 times t squared. Okay, if you solve that with the general formula, you're gonna get two results. The first one is 6.29 seconds, and the second one is minus 3.29. Okay, whenever you find negative times, just must say no. Okay, because this guy is gonna get angry. Okay, you just need to make sure you use the correct time. Most of the time, it's just the positive time. Okay, so how long is it in the air? Your first answer is 6.29 seconds. Okay, that's the first one. The second one, how far from the raft does the package land? So here we are. Let me just change color into something different. I'm gonna use this purple, and here. Okay, so we need to find how much they travel from here to here. Okay, how much distance is this? Remember that the velocity and displacement in x has no acceleration, so velocity is constant. So we can know that x equals initial position in x plus the initial velocity in x times the time. Okay, so initial position is 0. Velocity in x is 0 cosine of theta times the time. That is going to be 0 plus 25 cosine of 36.9 times the time we just found, 6.29, and that is going to be 126 meters. Okay, so that's the answer to part B. Okay, now finally part C. We know that the helicopter is going to be continue flying, so we need to find the position after the package lands. Now, let me continue doing this nice drawing. This helicopter is going to keep on going all the way into here. Okay, so at the same time, let's pretend this is exactly over it. The position in X is going to be exactly the same. so it's gonna be here. We just need to find the position in y. Okay, so I'm gonna write A here, I'm gonna write B here, and I'm gonna write C over here. So C, we're gonna use exactly the same formula that we used in part A. It's gonna be y equals y0 plus v0y times t minus, no, actually no, because no, it does none of this part. Why is that? Because we're told that velocity is constant, okay? So we can't forget about acceleration. That's something that we need to read, and I almost forgot completely. And there we go. So initial position in y, it's 100 plus the velocity 0 sine of theta times time. That is 100 plus 25 sine of 36.9 times 6.29, and that's gonna give us 194.5 meters. Okay, this is my answer. Now, my total answer would be x equals 126. Once again, this is exactly the same because the movement index is constant. So I'm gonna use exactly the same one, and then y, it's gonna be the one I just computed. And this is my answer for part C.